Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, amazing people all over the world of crypto and blockchain globally. And I have another amazing guest for you today. This man, he is the founder and chief scientist at Truebit. His name is Jason Teutsch. Jason, welcome to the show.
Well, thanks for having me here.
You're very welcome. Very welcome. I'm looking forward to our conversation. And first question I ask everybody is this: is what is your background, and is it a logical background for what you're doing now?
Well, as a logician, I'm going to have to say yes. My degree is in mathematical logic, so yes. And among those people who go into logic, there are people who come in because they are naturally orderly, and those who seek order. I'm probably more in the second class. So, but I guess yeah, that's where I, and I entered into blockchain from an academic place. I actually published the first paper on Ethereum and CCS in 2015 before the network launched. So basically scaling Ethereum before there was Ethereum. So it's before L2s, and today this verification game that we introduced is used in all the optimistic rollups that are out today. So yes, that's a little bit about my background.
Great. Well, I want to dive into a little bit further. You have an extensive background in verification technology and computational transparency, right? Could you just elaborate a little bit on both of those?
Yeah, well, verification is probably in some sense more accurate than scalability. It's just, if you think about where we're starting from, it's not scalability in the sense of transaction throughput, which is what most people talk about in the blockchain. We were trying to give superpowers to the smart contracts so they could do large computations. Basically, we called it, if you look at the original white paper, it's called the scalable verification solution for blockchains, because what we're basically doing is providing attestations for smart contracts in a completely decentralized way. So the original Truebit on Ethereum is just a set of 18 smart contracts that have economic incentives, and you make a call to the contract and it magically calls back with the answer by recruiting random participants, I guess you can say. So that's really the beginning of how I got interested in verification. It was through the first thing that we were trying to provide verification for was blockchains, but later it became apparent that the rest of the world needs verification, and it's become increasingly more apparent as time goes on. And 10 years ago, frankly, we were simply too early. But I mean, now with AI and other, RWA, there are a lot of tariffs. There are a lot of sort of trends that are going on right now that make it much easier to explain why verification is so important and really what affects people's daily lives, whether you have it or not. I mean, so.
Yeah, I agree. I agree. It's getting better. So
What's getting better? Something's getting better. I have a good feeling about it too. But
nice. So I want to find out about Truebit Verify. What is Truebit Verify, and what problems do you solve in blockchain and Web3?
Sure. So Truebit Verify is what it sounds like. We provide attestations for code executions and API calls, but at a higher level, we're really a toolbox for applications that require verification. And so we really it's a lot of it is about risk mitigation and providing transparency for different sorts of applications that require it, especially when you get into the decentralized space, and you can't rely, for example, on reputation. You can still fall back on a technology that can prove data provenance, how data was processed, when it was processed, where it came from, those sorts of things. And so yes, that's roughly speaking the use here. I mean, in the case of AI, which I know is the topic for this podcast, you might want to, some of the things that you might prove are really simple stuff, like which model is being used for inference, right? I mean, you can prove the inference derives from, further prove that inference derives from the model. You can prove how it was trained, but it's really kind of, I mean, really basic questions that are, am I talking, am I learning from the model that I think I'm learning from? And these things can be reversed as well, because in certain situations you might want to be able to prove that you're not learning from certain models because you're trying to protect intellectual property, for example. But just to give an example of the reputation, there's a very popular paradigm in AI, which I call Airbnb for your GPU. This thesis is there's high demand for GPUs. There's high demand, but actually a shortage of GPUs. But there are some that may be sitting around spare, and so the idea is to match up spare GPUs with the demand. But of course, if you don't do the verification when you're farming out these questions, you're going to get, especially when there are incentives, you're going to find that people cheat, and if you don't check the work, you're going to get bogus stuff. So that's in a very simple way where verification comes into AI space, and it's a challenge. We've seen last year when IO.net released their network, they suddenly had, I think, 1.8 billion fake GPUs that showed up on the network. And this is the kind of thing that can happen if you don't do verification.
I think it's important because whenever I ask Chat GPT something, it comes back with incorrect data, and I'm like, how are they verifying it? How is that accurate? So I'm like, what is the best model? Is it these large language huge models, or is it something like like a machine learning model? What's like a federated learning? What's the best model actually to use?
I guess it depends what we're trying to solve, but I mean, verification is a whole package. There's a different tools that you want to use. I mean, there was a paper by Amit Goldwasser, Paradise, and Rothblum that came out a few months ago, which talked about self-proving models, exactly what you were talking about. Your AI is, let's say 80% of the time it nails it and gets it right. But what about the other 20% of the time? Can you get a model to sort of prove its own correctness? And they take sort of an interactive proof approach to this, which I think is, maybe one way to, it's a different flavor of verification, but it does intersect with the Truebit Verify style verification as well, in terms of if you were actually going to implement this, you would probably see something like that in the background. But in terms of, I mean, there are so many different types of machine learning models, and they're all good at different things. Like, you don't want to ask an LLM to solve a math problem, for example. I mean, they all have different strengths and weaknesses. So, but yes, I think that verification has become, it's always been important. It's just sort of manifesting itself in different ways over time.
Yeah, I see that too. So you said different ones are for good. So basically, what you're seeing out there in the market today, you're seeing a lot of silos and black boxes, right? Or the systems operate independently. There's no talking to each other, right? So is this similar to what you're solving? Or how do we? And if not, how do we get these systems to work better together?
Yeah, I do think you do see a sort of, what you said, a trend towards siloing back in these informations. If you think that AI is the new web search, now people who have content on their website are looking for ways to protect it, which means that one wouldn't expect everything to be, eventually it's not findable through the old methodology. But as I said, it's like, so if you're going to do, I guess, AI search in a decentralized way, and it's not run through, again, a trusted provider that everybody knows, like Google, and it's all these sort of, I don't know what you call them, satellite or decentralized arms, I guess, you're going to need to do some sort of verification on those entities that are providing information to you. I mean, they call them, when you start do a web search, they call it a verifiable snippet, the little thing that Google gives you so you don't have to click on any of the links, right? And so verifiable, again, if you always wonder, like, is it giving me, how do I know if a verifiable snippet, like if it wasn't Google providing me a verifiable snippet, but like, MrSnippet.com or something, like you'd want to double check it in some way. And the way that we check things is changing. Like in the 1980s, if you held up a Polaroid, you waved a Polaroid picture in the air, that was as good as a proof. Today, like, an image isn't worth very much, and we need a different set of tools to basically, what you used to be able to sort of eyeball, you're going to have to use machines to figure it out. And it's just been sort of that trend. When people first started talking about fake news, if you really went out and searched, you could find what you were looking for. But with AI, that's, the signal to noise ratio continues to drop off, and you need more and more machines to deal with the machines, basically, so that you can find the information that you're looking for and believe it. Yeah.
So it made me think about something. I just got my driver's license renewed, and there's a stamp on it. Thank you. It's good through 2033. I mean, I can drive, right? There's a little mark in the corner called Real ID, right? I didn't send them my latest picture. I guess I'm gonna have to be young until 2033, right? Looking or whatever. But that picture was taken 6 years ago. But how do you know, that, how do you, like, is Real ID the use for transparency and verification, or how can they prove that it's me in some other way? Why is verification and transparent becoming, very critical? Like, because somebody could say they're me and they could drive my car, right? Why is it so important now than it was before?
Well, I think it was always important. The Real ID is just a perfect example of what I said a minute ago, that the standards are changing. And for whatever reason, the government decided that what they were doing before wasn't providing them, the system they had before wasn't providing the type of verification that they needed. Now, whether you'll need a driver's license at all by 2033, because, maybe drivers will be banned altogether and we'll just be driving around in AI taxis, that's a different story. But I guess I hope I'm answering your question, but it's sort of, yeah, I don't know. All I could say, these things change over time, and the way that AI, I mean, I was a bit shocked. I entered back into the United States a few months ago, walked through the passport control. I didn't even pull out my passport coming into the US. They just said, "Hi, Jason." And that, I was like, really? Are we really doing this? I mean, like, so, I just anyway. So yeah. I again, all these things, it raises the question of accuracy. What are we actually? What information do we need to get the job done, and how reliable does it need to be? If you're asking AI to make financial trades for you, or drive your car, or do medical procedures, you're going to want a really high level of certainty about these things, which, right? I mean, and there's always going to be the models are probabilistic for the most part. So we got to put some effort into basically getting the data into a place where it's usable.
Yeah, so you make a good point there about certainty, right? So how could verification technology address, I guess, certainty goes along with accountability, and apparently there's an accountability crisis here that exists in AI with regard to certainty. So how could verification technology potentially address that certainty issue?
So I think I've mentioned a few tools already on this call, so I'll just recount them and we can dive in deeper or maybe add to the list. But this self-proving models is an interesting one. When we're doing Truebit is another. I mean, the one place I'd add on Truebit Verify in terms of sort of bringing data provenance, proving that you're interacting with the model that you think you are, proving that it's doing the inference in the way you expect it to, proving that it's trained on the way any kind of semantic proofs that you can prove about the model too. That's another form. And then on top of that, anytime you're going to be processing data, there are all kinds of little, what do you call them? Data cleaning, like little processes that you have to do to interpret the data. I mean, this is a place where Truebit Verify is really immediately useful, because you can write a few lines of JavaScript code and have a proof written up within seconds. So that's I mean, from the time you write have the code written, well, hey, have an AI write look at the pipeline we're looking at, like with vibe coding catching on. You're going to have an AI that comes in, writes a code based off of talking to you for 3 seconds. And then off of that, you would be able to generate some sort of proof that this scripting process of processing of the data is done correctly. I mean, there's just like, you need it. What I've noticed, having sat in this verification spot for so many years, is that when someone says, I want verification, they aren't saying, well, I just need I need a ZK proof for this little thing. I mean, occasionally you are, if you're living in the blockchain space and everything is, basically it's the one place where everything is certain and data doesn't disappear. But the real world isn't like that. So if you're sitting in this place where data is basically, once someone says I want verification, they want it end to end, because your verification is only as good as the weakest link in that whole pipeline, basically. And so yeah, basically that's what I've observed, and so then you question, where do the inputs come from, and every step along the way, who's been involved in the processing. And more we're seeing third parties being involved with processing the data, right? When you have one central party that's doing everything, like, I don't know, let's give Google as the example. If Google is doing everything itself, then you can sort of rely on Google. But as we get more into turn to the decentralized world, as AI is sort of forcing us in that direction, it creates more and more uncertainty that has to be offset. I really see Truebit Verify as a counterweight to this AI movement, and you can't really have one without the other.
That makes sense. So there's a couple of areas to go down here. One is One is the data, right? So I want to find out, with Truebit Verify, and looking specifically at blockchains first, right? In the area of data, you mentioned ZK proofs. Another area that data is important is decentralized Oracle networks and oracles. Are we going to need to have those anymore, ZK proofs and oracles and all this, or can we just rely on the AI agents, AI models, Truebit Verify, to bypass this the need for those for proofs and for Oracle?
I think you need all three. You're going to have to combine them together. I mean, really, the power in this is to create the whole package, right? It's not just an Oracle. It's not just compute. It's how do you, I mean, and that's what we've sort of been focused on with Truebit Verify. Normally what one does is that I need to pull in the data, then I need to process the data, and then I need to send it somewhere else. That's a super common pattern. And so, just getting one piece of the puzzle is not enough. And often the data you're pulling might be in an AI model itself, which is, we have a study that we just put out on Deep3, which you can find on the website, which sort of addresses this problem specifically in the AI space, which is to say, you can prove that, okay, I'm going to let the AI do certain, and using different kinds of models that are out there, and then being able to prove that those models are functioning in the way that they claim to be, or that I expect them to be. And sometimes it's not a matter of deceit, it's just misunderstanding. If you one person might assume that the code is doing one thing, and the other one assumes the person who created it assumes something else, and you just end up with a mismatch where people don't, you end up with mistakes, not because someone is malicious, but simply because you didn't go down to the level of code. I didn't see what came before it in the pipeline. I thought the model was trained this way, but it was actually trained that way. This sort of thing comes up. And I'll tell one more story here, but it was like, we had someone who was working with NOAA, the weather data. So you might say, well, why do I need to verify data that comes from NOAA? It's always going to be there until one day it wasn't, right? I mean, but if you have the certificates proving, then you're okay. You can just sort of keep going. And we've seen it's a recurring thing where APIs and information of websites disappears suddenly without any warning, and people are left to scramble. But if you, at least you can protect your historical stuff with proper data provenance. I mean, it's just sort of a common sense thing to do. And there's not a lot of overhead either, right? Instead of our play view, it's like, instead of running JavaScript on an ordinary cloud, just execute it over Truebit, and it'll do the same thing, but you'll also get a certificate, a transcript, basically attestation that goes along with it. So you can do these things. It's not that complicated, I guess is what I'm saying. I mean, I'm not saying Truebit Verify isn't complicated, but we're trying to make this easy, because I've seen a lot of ad hoc verification solutions that just simply never get finished or never get up to sort of production level standards. But everyone always has sort of the intention to do it. So that's an interesting challenge. But really, the other reason to do it isn't just because it's common sense, but because it adds value. Like when you get into RWA, the more you verify, the lower the risk is for investors, and therefore the assets are worth more. You increase the demand for your assets by providing proper verification. So there's different, I guess, categories of risk. I've talked about, I mean, you have counterparty risk is another one. We sort of jumped in that with the Airbnb for your GPU example. And then Reputation is becoming overweighted as well, because we've seen no matter how big an organization gets, there's or how much credence people give to them, they sometimes things happen, right? so that's the more I personally think there's another, you can also think of verification as simply an insurance policy, because what we should be doing is pre-auditing stuff so that bad things don't happen, versus 5 years later coming back and litigating them. I mean, just think about this Feeding the Future that raised $240 million to feed children during the pandemic. The only problem was those children didn't exist. So right, and now we're 5 years later. There's a lot of pain and upset. There's a lot of pain, like, which could have been avoided if we just did the verification in the first place. So it's this is the way that things have to go. We need to change the sort of paradigm, and it shouldn't. The question shouldn't be asking the question, why should I do verification? The question should be, why aren't you doing verification? Because that's ultimately where this goes. And the sooner we get there, I think, the better.
I want to talk about a practical example that to me seems like it needs verification. I don't know if you've been following this whole Newark airport thing where the air traffic controllers went on strike. And it was just a mess in Newark. But their systems are old software from that was created in the 1940s. They're not using AI, they're not using agents, and then it's been a mess. So what would a world with verified AI systems, especially in the area of critical important areas like air traffic control, look like as they were compared to today?
I don't know. Why would you want to throw AI at air traffic control? That just like what we know how to land planes. I mean, I guess you can model these things out, but I don't know that AI is always adding AI to the beginning of the sentence doesn't always make it better. Like, the air traffic control is a place where you want absolute certainty. I mean, I don't know if the idea is to sort of cut costs, or what's the problem we're trying to solve here? Maybe I missed the point, but I think places where you need absolute certainty, you got to create a system which allows you to have that level of confidence through verification of whatever the standard is. And it may be just that there's a centralized controller that everybody trusts, and that's pretty much. I mean, in all these cases, anytime that you're going to do verification, there's always some sort of kernel of trust where there's always some ground truth or something that you fall back on, even if it's just like an API call that has nothing to do with this particular big API call that's everybody trusts, a call to, I don't know, what somebody that everybody trusts, weather.com, like something really, like they're not they don't care about the deal that you made with your crypto bro friend about what the weather was going to be on next Thursday. Or last Thursday, I guess is more like it. Usually, I don't know, the thing about predictions is they're usually about the future, but I guess, what do you think? I mean, is there another angle here?
Yeah, there is.
Okay, go ahead.
A lot of people are fearful that if the accountability issues with AI go unchecked and undealt with, that we're going to face an AI Armageddon, like in Total Recall, or like some kind of sci-fi movie. That there's going to be an AI Armageddon. So if there is one, how do you come back from one?
Sure. Oh, you mean assuming that we made this mistake, how do you correct it?
Yeah, we're along the line, and then everything's chaos. How do you correct it?
Sure. I mean, I guess my point of view is let's prevent it from happening. But assuming you're in a situation like that, Yeah, I guess if the AIs have already in place, you can see if you can get them to run in more verified ways. I mean, I guess that's certainly true, but I don't know. It's hard to, without knowing what the disaster is, it's hard to come up with a solution for it. I assume there's also the option is to pull out the cord, right? I mean, you said that that's one place where humans have it over machines in theory. You know, they can switch off, we can switch off the power grid, maybe at least in the current scheme. So you hit the reset button, you start over. I mean, if there are ways to get it back on track, obviously you do that. If you notice there's a problem with a particular system, you try to get out the bugs or phase it out. I mean, there are a lot of strategies that one could put to work, but you know, an ounce of prevention is worth a pound of cure for sure.
I like that. An ounce of prevention is worth a pound of cure. I like that. I'm going to use it. So going back to the blockchain, right? You know, that the intersection of blockchain and AI, the biggest technical challenges in bringing blockchain in line with AI as far as valid verification. What are those technical challenges, and how do you see Truebit helping shape the more accountable AI future?
That's a great question. I mean, let the elephant in the room. Obviously, AIs are big. Blockchains have small compute capabilities, and that's the roots of Truebit. Is about taking. The assumption was always that smart contracts compute correctly. Which, by the way, you never say to someone, "Hey, my smart contract computed wrong." Take that and sort of poof it up. How do we expand the power of smart contract? And it's the same thing that we're doing in the real world, taking different points of trust and trying to poof those out into applications that people can really use. So you have just the sort of general complexity question of how do I execute AI? So obviously scaling of computations and scaling of data can be challenges. Obviously, there's a lot of data on the blockchain already, which for those types of applications, if that blockchain is capable of accessing its own data, again, that's another place where you can understand the power of making API calls in addition to simply running everything as a, you know, you need a way to get the data back into the smart contract, even if it's on the blockchain. So you have these challenges, and we have Truebit. You know, we'll talk about smart contracts. I mean, we'll be sharing soon, you know, example of a smart contract where you basically said you can just paste in JavaScript code, have it into the smart contract, and then have that basically execute the code. You make a call out, calls back in. So this is one. You asked me how Truebit Verify. That's sort of a really simple application which shows the power of off-chain compute coupled with sort of the Oracle processes we're saying with these API calls. But the second point that I would probably point out is non-determinism is a huge issue because of the way that these AI models work. You have non-determinism. Getting the blockchain is very deterministic. In cases where you need to get consensus, that's a big problem because two people might do the computation correctly and get two different answers. That's what non-determinism means. And so insofar as that's an issue, you know, how if everything has to be on consensus, how are you going to get consensus on AI? And you know, there are various sources of these non-determinism. You got the floating point is a big one, and the consequences of that, which, you know, sort of non-associative operations, which also come up in other places, you know, NAN, and also people running different types of hardware as well. So you can execute the same model in different places and get different answers. So in the blockchain world where everything has to work by consensus, this is a problem. However, I do think there is a way. A lot of times this consensus is overkill. And I think what people really want is not necessarily consensus, but simply auditability. I want to be able to prove that going back, if something was wrong, that, I can't stop something wrong from happening, but I can quickly discern that's what happened. I mean, this is essentially the use case. That is the use case for Truebit Verify, when you just need auditability. And if you relax this requirement a little bit, you get something which is faster, cheaper, easy to use, and all these things that really fit the real world needs. And so, yeah, I sort of think that this is, combining these things together. I mean, there are use cases where you do need consensus, but it's this obsession with smart contracts has led to a bit of overuse, I would say. And the question doesn't have to be, well, how do I get data into the smart contract? How do you get it back out? Ask yourself, why is it there in the first place? So that's kind of a question. But,
So it's kind of like the smart contract's not always needed,
It's you're jamming stuff in I mean, it's a small hole and you're trying to jam something big in there. Like, sure, maybe it'll fit, but there might be, if what you really want is auditability, then that might not be your easiest solution.
Got it. Interesting. So, a couple last questions.
Great.
One, what do you see as the future for building out Truebit Verify? What do you see as your roadmap in the next few years? How do you see people being able to literally leverage your technology?
So I mentioned, I think we have there are a lot of pieces actually that can be added to sort of broaden out the verification needs. I mean, privacy is a really big theme. We obviously bringing in ZK snarks to protect some of the data that people want to bring in through API calls is significant, and making the yeah, all kinds of privacy aspects are there. Also, sort of the ease of use of combining these tasks together. Like, you're going to get a whole envelope full of these certificates. Now you're going to have to manage those. So I think that's sort of the inevitable. Like, if we can, providing tooling that makes those sorts of things easier. And I think, yeah, also, we're going to be talking about, handling larger and larger files, which is something that you need for AI processing, and more language supports. I mean, there are all kinds of things. These get down to sort of technical sort of development, but really what I think it also comes down to sort of supporting specific applications and having enough templates out there that people see in common. Everybody wants to do an airdrop. Great. Here's sort of a tool for doing the airdrop. And so you don't have to think at the level of code, really. So I think that's really a few different pieces of it. But thank you for asking.
Yeah, you're welcome. Yeah, awesome. So I want to thank you very much for your time today. I enjoyed speaking with you. My final question is, how can people find out more information about you and about Truebit Verify?
Sure. Well, you can certainly go to our website at truebit.io, and follow us on Twitter. I'm also Jason Teutsch on Twitter, and please feel free to reach out with any questions. We try it out. And so yeah, we love getting feedback from our users.
Awesome. Thank you very much for your time today.
All right. Thank you so much.